Hi everybody, it's Jonathan Davis here. I work for Trimble out of New Zealand. I hope this finds everybody safe and well in these challenging times. I'd just like to say thanks for attending the webinar and welcome to this session on Trimble SiteVision. Just some housekeeping matters before we get started. There's a lot of people on the live session here. So again, thank you for taking some time out of your day. But with so many people on the session, it's too many to have everyone off mute and asking questions, etc. So what I do is invite you to ask questions or enter questions into the chat at any time. And then at the end of the session, we will spend some time trying to go through the questions that come in. So today we'll look at the Trimble Mixed Reality program to begin with, since there's a lot of terminology, I think, in this augmented reality or mixed reality space, and I think it's worth just spending a couple of minutes clarifying what some of those terms mean. And then we'll run through the SiteVision system, what it is, how the technology works, and then we'll have some example use cases, and then, like I said, we'll spend some time at the end on some questions and answers. So just starting off with a short introduction. Like I said, my name's Jonathan Davis. I've worked for Trimble for about 20 years, located in New Zealand. And I've recruited 3 of my colleagues from around New Zealand and Australia to help me with the presentation today. So Warren Eade from Alterra in Christchurch in New Zealand, Scott Barling from UPG just out of Sydney in Australia, and Ian Sunderland with Hifali Leisner Geospatial in Perth in Western Australia. And these gentlemen work for some of our distribution partners across the New Zealand and Australia region, and they're helping me today by presenting some use cases of how their customers are using the SiteVision technology. So before we get started with SiteVision, I think it's worth spending some moments just understanding or aligning ourselves on what some of these different terms mean, because there are certainly more than one, and I think it's easy sometimes to get confused between what is virtual reality compared with, for example, augmented reality. So virtual reality, I think, is the one that most people are familiar with. It comes from the gaming industry, I think, mostly. And the distinction with virtual reality is that it's fully immersive and the user is restricted to only the digital content. So it takes them into a completely different world, and their physical location, whether it be in your lounge room or wherever in your office, actually doesn't make a lot of difference. Augmented reality, on the other hand, is the combination of the physical world and the digital world. And in terms of SiteVision, that is overlaying digital information on a video stream on a mobile device, and that's what we'll discuss more in a moment. And then just completing the terminology here with another term that you might have heard called mixed reality, and that's very similar to augmented reality. The way that we in Trimble define mixed reality is it's similar to AR, but it's in a hands-free or it's a hands-free experience, and it's in a more confined environment as well. If you look at the Trimble technology in this space, we touch all of the different types of reality that I defined on the previous slide. If you look at our hardware platforms, however, we have Trimble SiteVision at the top there, which is specifically designed for use outdoors. And then we have the Trimble XR10 system, which is more designed for building construction applications. And that's based off the HoloLens 2 platform that comes from Microsoft. And that is more suited to sort of more constrained environments. I don't want to say it doesn't work outdoors, but it's certainly more suited to sort of more constrained or indoor environments. But what we're here to talk about today, of course, is Trimble SiteVision. And what is Trimble SiteVision? It's a high accuracy augmented reality system that's designed to be used outdoors, and that outdoor piece is a very important distinguishing factor. It allows customers to not only visualize data sets in the context of the real environment, but also the ability to interact with those data sets, and I'll explain how that works over the coming slides. So in terms of visualizing the data, it enables improved communication, it enables improved collaboration across projects, across sites, for different types of data sets. It can be things that are hidden, it can be things that are not yet constructed, as in the graphic on the right-hand side, which shows a residential development overlaid on an empty green field. Or it could be something else, something like a thematic map that's on the ground. And I like sharing some of these concepts with pictures. So we'll get into some more of the technical details soon, but I just wanted to share some pictures to start. So things that are hidden, one of the obvious examples would be underground utilities. And these shots that I'm showing are images from the SiteVision system being used out in the field. So here's an example of being able to view some underground utilities. Here is getting more into the architecture space. This is not a picture of an actual house. The house is a model that's come from the architect, and using SiteVision, it's been placed on site. If you move around the model, you can look at it from different angles. And then if you walk into the space or across the site so that you're standing in the center of the model, it even gives you the ability to look out the window and really understand the design and collaborate with the architect and say, I like this, but I don't like that. A lot of us or a lot of people in general are limited in how they can interpret certainly 2D plans. But even 3D renderings and fly-throughs provide a limited ability to really internalize and digest and understand the information. So the ability to navigate through the model and on site in the context of the physical environment really does help that communication and collaboration. Another example might be a road alignment or a realignment in this case. Helping the crews detect clashes perhaps with existing infrastructure before the ground is broken, so saving a lot of potential cost savings there. And then just another example here is a model of power transmission lines over the landscape. So it could be through the as part of the consenting process, using this technology to show the various stakeholders, what the environmental impact will be of building this infrastructure. And then the third category was thematic maps on the ground, and what that means is it's not a model as such, but it's a layer of information. In this case, it's a cut fill map. So in the civil earthworks space, this can be particularly useful as the sites become more and more stateless, so to speak. So there's less and less visual information actually on the site to indicate how much work remains as the models are loaded directly into the machinery. So something like SiteVision using a thematic map like this that shows the different cut and fill values in the form of a heat map can really give the site supervisor a good idea of what work remains. And then just a couple of others here. This one is showing a residential property boundary line. And then something else entirely, if we look at an application like bridge inspection, if you've got, it sort of brings or introduces the concept of the digital twin. In this case, we've got a model of something that already exists, but by turning on and off the layers of the model and isolating or only displaying the elements of the model that you're interested in, it could be an easy way to go to a piece of infrastructure like a bridge and identify the elements that you need to inspect. So I've got some more examples coming up, but I just, like I said, I really like looking at things in pictures. So I just wanted to provide some sort of introduction, to how the technology can be used across a few different types of applications. But now let's get into the technology and have a look at how it actually works. And on this slide, you can see the various technology components that come together to create the SiteVision system. So what's really unique about this system is the coming together of the high accuracy GNSS with the electronic distance meter and the AR capability of the Android operating system. And they are the core components that come together that deliver, the experience that I was showing you in the previous images, and that you'll see in the upcoming examples as well. So it's the combination of the high accuracy GNSS, so having a centimeter level accurate position in your hand, and then combining that with the AR capabilities of the device and the ability to measure to different objects in your surroundings as well, which is one of the ways that you can interact with the model that I'll get to in a second. So in addition to those, there's also the SiteVision app, of course, that runs on the device. Behind the SiteVision app is the Trimble Connect cloud platform, which is a sort of a project management or a project collaboration tool that's in the cloud, or it's a cloud platform. And that is the mechanism that you use to deliver the data sets to the SiteVision app. And then there's a power management aspect as well. Up in the handle, there's a battery and it comes with a charger and things as well. So if we step back from the handheld itself, when we look at the overall workflow, the first thing that you need to do is prepare the data. And that's a critically important step. Like a lot of things in life, I guess, rubbish in, rubbish out. So preparing the data set is a really, really important part of the workflow. We've found as the SiteVision technology is used more in the marketplace, that customers that thought they had a good data set are actually discovering that their data isn't as good as they thought it was once they bring it into the system and try to view it on site. So it really just underscores the critical nature of the data prep. And in terms of the types of data that you can load into the system, it supports most of the common survey, civil, GIS, and CAD data formats. And the elements that can come into the system within those various data formats are points, lines, surfaces. The system can use attribute information to help render some of the objects, and the objects can be textured as well. And I've got a table coming later that shows exactly all of the different formats that can be or that are supported by the system. So again, very, very important step is preparing your data. Step number 2 is uploading the data to our cloud platform. And then step number 3 is when you're in the field with your device, with your SiteVision device, you sign into or start the app and sign into the application. You load the model, and then there could be an intermediate step to place the model on site, depending on how well you've prepared your data. I'll talk more about that soon. But once the model's loaded and it's placed on site, then you can move through the site and visualize and interact with your data set. So just, I mentioned there's possibly an intermediate step placing the data depending on the data set you have and how it's been prepared. So there are 3 ways that the SiteVision system can use to place the model or the data set on site. The first there is automatic. So if your data set is geo-referenced, when you bring it onto SiteVision, then it should magically appear in the right place. Of course, you need to have your coordinate system settings configured appropriately. But if you've got a geo-reference model, it's actually not too hard to have that model just appear automatically in the right place on site, and that's by far the most accurate way of doing it. But like I said before, it does rely on having well-prepared data. If your data isn't geo-referenced, or if you're having problems having it appear automatically on site, then there are a couple of additional methods. The first one is a measured placement, and what that is similar to, well, you can think of it in a similar way to a GNSS site calibration. It's a real-time geo-referencing of the model. So that option that you can see on the screen there, you select place model, then measure. Then it's going to walk you through a couple of steps where you select a point on the model, you measure the corresponding point on site with the GNSS. You do that 2 times, and then that places, or that sort of pins the model down using those GNSS measured points on the site. And if you do a measured placement, then that placement is actually saved up into the Connect project where the data or where the model resides. And then any other SiteVision system or SiteVision users or systems that are on site viewing the same model, when they load the model, they will also bring down the measured placement that you made on site as well. So all of the systems operating on the same site will see the model in the same place. And then the third model placement method here is a manual placement, and that is literally using your fingers on the screen to sort of drag and drop the model on site. So it's very easy. It's very effective when for example, when we're sort of showing an overview of the workflow and we don't have necessarily a geo-reference model handy for that demo location. But it's certainly the least accurate placement method because you're relying on your fat fingers on the screen of the device. So yeah, just some tips there, I suppose. The automatic placement method is by far the most accurate, and again, it all goes back to how good your data prep is. So once you've placed your model on site, hopefully it's happened automatically, but once the model's placed on site and you're sort of in the main interface of the SiteVision application on the device, this is what the screen looks like. And I've got a couple of videos coming later, but I'm trying to not have too many videos here because of the lag of doing this online. But what this is it's a live video stream with some graphics and things imposed over the video stream. So I'll just quickly describe what the various icons and bits and pieces mean, and then we'll get into a little bit more of how some of the tools work. So up in the top left-hand corner, there are 2 icons. They're both green in this image. That shows the position status, which is the status of the GNSS position, current GNSS position that the integrated GNSS has, and then the compass below it is showing the orientation status. So when you start the system, it takes a few moments for the GNSS to sort of locate itself, and you need to wait for the GNSS to have converged down to the desired accuracy before you can start using any of the other tools. So that's why it's a sort of a traffic light system. It goes from red and then ultimately to green once it's reached the desired accuracy, and you have to wait for that position to go green before you can use the rest of the system. The GNSS will go green, once it's connected, or once the accuracy has been achieved, and then it's going to ask you to walk 10 meters. And the reason it asks you to walk 10 meters is so that the system can get its orientation. And what it does is it asks you to walk 10 meters, and it uses the sequential GNSS positions to give the system a very good orientation. And that feeds the orientation into the AR of the Android device. And from there, the system is ready to visualize the various data sets on site. So the first thing to do is to get the position status and the orientation status to green. If we go in a clockwise direction, we go across to a button in the top right, which is allowing you to control the layers of the data set that you see. So depending on how the data has been prepared, if it's been prepared in a number of layers, then you can turn layers on and off. I think back to the bridge inspection example I gave before, where you can turn various components off. So you're only visualizing the components of the bridge that are interesting to you. If we keep going clockwise, the cube there allows you to toggle between a 2D view and a 3D view. The 3D view is what we see right now, which is the live video stream. And then the 2D view is going to give you a top-down map, which shows your location relative to your model or the data set that you've got loaded. Continuing clockwise, the next one is model transparency, and I'll come back to that in a second. We've got two left. The next one is the application menu, and that menu button opens up a number of routines that allow you to interact with the model, and I'll come back to that in a second as well. And then last but not least, on the bottom right is the main menu, and that's the one that I showed on a previous slide that allow you to do things like load a model. If you don't have an automatic placement, you can select to do a measured placement or a manual placement, and then that's where the various settings exist as well. But if we just focus our attention for a moment on the model transparency slider there. So I have loaded my model. It has been placed automatically. At the moment, you can see the transparency slider is all the way to the left, which means the model's invisible. And if I slide that across to the right, then you can see my model, which in this case is a wind turbine, appears in the right place up on the hill there. And then when the model's visible like that, then you can obviously navigate or move around the site and look at the model as if it was a physical object actually on site. So I look at the one on the top right, and you can see the GNSS status is saying that it's tracking 10 satellites and the positional accuracy is 3 centimeters. So that's really achieving those higher accuracy precisions there, and if you can really go in close to the ground and see the corner of the model is really glued on the ground there. So this was just a sample. I pulled this object out of our SketchUp 3D warehouse and then located it on this site here and near Blenheim, where I live in New Zealand. But if this was a site, for example, where there was some construction planned, then perhaps the foundation is already poured, then I can come in and this model, assuming that everything has been done correctly, this model would appear sort of within that 2 to 3 centimeter accuracy, sitting on top of the foundation. And I've demoed that several different times where, for the surveyors out there, where we are staking out an IFC model with an SX10, for example, and then we load the same model in terms of the same coordinate system into a SiteVision device, and then standing next to the survey rod, you look at the tip of the rod through the SiteVision system, and when the tip of the rod is on the corner of the foundation, for example, or whatever component of the model it might be, the view through SiteVision, is within sort of 2-3 centimeters of what's being set out. So it's a very, very accurate system. In terms of one of the things that really brings a lot of value to the system are the various visualization tools. So, the previous slide showed the ability to see an object as if it was, there in your physical environment. But in addition to that, there's a whole lot of very innovative and intuitive visualization tools that are available in the software as well. So again, if we start with the transparency, I think we covered that one. So we'll go clockwise again, and we'll go to the minimum view distance, and then just around the corner there's the maximum view distance. And what that is doing is it's sort of allowing you to push back or to increase the minimum distance. So you think of that as if you're sitting inside the model and you're facing in a certain direction, if you move that slider, it's going to sort of hide the model that's right in front of you up to whatever that distance is that you set. And then the maximum view distance, likewise, is going to pull back the amount of model that you can see. So I'm not sure I'm explaining that particularly clearly, but if you use the two in combination, you can create some really nice cross-section views by limiting how close or what the minimum view distance is and what the maximum view distance is. If we continue clockwise, if you click on the screen on one of the elements of the model, then assuming that the data has some attributes, then the attributes will be shown in the screen here. And if we keep going around, there's the layer control. So I mentioned that already. Especially if you've got some GIS data or a utility or GIS data set, there's often a lot of layers there. So that's gives you the ability to turn on and off, the various layers that are in your data set. And then one of the really nice features of the SiteVision system is what's known as pit view. And that's the two sliders and the drop down, and then you can see the little icon of the pit there. And at the moment on this screen, I've got pit view turned on. And what pit view does is it gives you a lot better perspective, or a lot sort of better context when you're looking at data that goes below ground. So if you have pit view turned off, then you see the model in its entirety. But as you move across the site, those pieces of the model that are either, usually the pieces of the model that are below ground by any significant distance, they will move at a different speed to the components of the model that are at the ground level. And the end result is it looks like the model is moving across the ground with you. But if you turn pit view on, like I've got in this screenshot, it actually hides everything. All of the model that's below ground gets hidden, and the only parts of the model that are below ground that you can see are what is down in the pit. So the pit is this yellow hole that's or virtual hole that's in the ground, and it's got some graduations around the side to sort of help with your perspective as well. And you can so you sort of lean down and look forward and look down the hole, and in this case you can see this is a steel structure, or an IFC model of a steel structure, and you can see the foundations there going down into the ground. And if you look on the right hand side of the pit, you can see that just the top of that brown element is above ground, and what's below ground has been hidden. So this really helps you sort of visualize the model in terms of what's above and below ground. And then the drop down and then the two sliders, they're just changing the shape of the pit and the size and the depth of the pit as well. So some really innovative visualization tools that really help bring a lot more perspective to to your visualizations depending on the type of data that you've got loaded. So now we'll go to the applications button, and what this does, this is when I say you can visualize your data and you can interact with your data, it's the routines that are available using this applications button, which is what I'm talking about when I say you can interact with your data. So the first one there, which is create task. So if you select that application or that routine, that's going to take a screenshot, and then it's going to give you the ability to enter some text. Maybe you've detected a clash with your design and something that's in the physical environment. So you can take a shot of that. You can enter some information about what you see, and then it also allows you to, I think, set a priority and assign it to somebody that's within the Trimble Connect project. So that's task creation. And then the next three, measure point, measure cut fill, and measure slope and distance, those routines allow you to collect additional data or collect new data using the SiteVision system. So measure point, that allows you to sort of, as is probably quite obvious, to measure a new point. Measure cut and fill. If you have a terrain model in your data set, you can select to measure the cut and fill, and you can, the point that you measure, it'll give you the cut and fill relative to the design surface at that point where you measure. And then measuring the slope and distance is, I sort of think of that as measuring the relationship between 2 points. So that routine will guide you through the measurement of 2 different points, and then it will give you the slope and distance between them. And for those, measuring the point, the cut, fill, and the slope and distance, you've got some different options in terms of the measurement technologies that you can use for those. So as I was talking about earlier, the SiteVision system includes a high accuracy GNSS system. It includes an electronic distance meter. And then we've added a third one here, which is augmented reality. So the GNSS, as you might expect, it just measures a point using the GNSS and the handheld. The EDM uses the laser that comes out the front to measure a point that might be remote from where you're currently located. So it might be over a fence, over a river, up on the side of a building, something that you might not be able to visit. And then augmented reality allows you to select a point on the model. And I have an example of this on the next slide. So this is sort of an example scenario, but you can see here I've selected to measure the grade and distance. So it's guided me to measure 2 different points. My first point was on the side of the shed, and it's represented by the blue bubble. My second point, and I used the electronic distance meter to measure the point on the shed just by aiming at the crosshair that you can see on the shed. And then I changed the measurement technologies to AR, and then I was able to select the point on the model, which is the little blue bubble, which is sort of on the green component of the model there. And then once I've measured those 2 points, the system then gives me the information that you can see there, which is the grade and the slope distance, the horizontal distance, and the vertical distance between those 2 points. So in this instance, the example could be if I've got an existing structure and a design, I can use the combination of the measurement technologies and this measure, grade, and distance routine to check the clearance between the proposed and the existing structure, not on a plan on my desk, but actually out on site using using these measurement technologies. And when you're measuring points and when you're measuring the grade and distance, you can use any combination of those measurement technologies as well. So in this instance, I've used the EDM to measure the side of the shed, and I've used the AR technology to select a point on the model. I could just as well have used the EDM for both points to measure two sort of physical points. I could have used the GNSS to measure two physical points, or I could have used the AR to select two different points on the model, or any combination of the above. So it's a very, very flexible system. And then just one other note, you know, most of the examples and context of what I've been describing has been in terms of sort of a 3D model, if you like, or at times, you know, a surface. Well, SiteVision is very, very useful tool, certainly in the utility space, or sort of more in the GIS space in general. And that is, if we think about utility data for a second, the data actually exists just as points and lines. And if you bring that data into SiteVision, then by default, what you'll see are the lines on the shot on the left-hand side there. Using a desktop utility application called SiteVision Visualisation Manager, you can create sort of easily create a pretty simple rule set that helps SiteVision interpret the data set, and it will use the attribute information to not just display points and lines, but actually to display 3D objects on site. So it's and then there's an example of that on the bottom right there. So you can see the red line there is an electric utility, and you can actually see that a little bit faint, but you can just see some grey lampposts above the corners of that red line. That yellow line is stormwater, and that line actually has a diameter. It's a 3D object. It's just this view doesn't show that particularly well. But you can also see some manholes there. You can see some fire hydrants. You can actually see a tree in the center of the screen there as well. So it really brings, you know, what would otherwise be points and lines, it can really bring this sort of GIS and utility data to life. And here's another simple example as well. So on the shot on the left, there's just a simple line feature, and then there are 4 point features. Using the attribute information that was collected when these features were picked up, the system can interpret that attribute information, and then when I go out into the field and visualize it through SiteVision with the rule set created with the utility app, it will render these some objects in 3D. So the culvert there is being rendered as a 3D object, and then on those points down the fence line, I think there's a couple of apple trees and maybe a couple of oak trees too, just to show the different types of objects that can be used here. So just before we sort of bounce over to my colleagues to show some of their customer examples, I just wanted to spend a moment on this screen that shows all of the different data formats that are supported with the SiteVision system. And then not just the data formats, but all of the different types of objects and data that can come across in those various data formats as well. I'm not going to go through this line by line, but it shows a range of Trimble formats in the yellow, and then there are some open industry standard formats in the blue, and then some third-party formats there in the green. But it's a very flexible system, and it's supporting most sort of survey, construction, building construction, CAD, BIM, you know, civil, utility, GIS data sets that are commonplace in the market. And even if you don't know anything about what any of these data formats are, then, you know, there are some pretty easy solutions that we can build that allow you to, you know, using some of our other technologies that allow you to collect the data sets and then visualize them in SiteVision as well, without, you know, needing to know the various data formats. So with that, I'll hand over. We'll go from west to east. So I'm located in Blenheim in New Zealand, which is sort of in the middle of the country there. So we're going to bounce across to Ian in Perth, and he's going to show us how one of his customers has been using SiteVision. Ian.
Thanks, John. Yeah, as John has already mentioned, I work with the Trimble distributor in Perth, HL Geospatial. I've been there for about 2.5 years. Much of our business, as you'd expect, is in the mining community, one of the industries that's been able to keep going fairly strong during these times. And one of our customers really recently did a trial with us with SiteVision. John, if you just want to start going through the slides. So one of the problems faced in mining is they have a lot of complex spatial data, from block models to models of their different rock types and their geology, and mining software has tended to be quite good in the 3D space for quite a while, and there's always been a difficulty transitioning that to the field, and SiteVision is really starting to help with this. What we see here on the left is an actual image of their some of their ore blocks in Trimble Connect, and on the right we can see it brought with SiteVision to the field. Next slide, John, please. So the customer is one of the top 10 gold producers in the world. They have a mine in Western Australia where they've been given a mandate to utilize the latest technology to improve their efficiency and to improve their safety. So they already have existing softwares on site for general mine planning packages like you'd find on a lot of sites. They have S.U.E and Datamine as well. So the main data that they want to see in the field generally sits in those packages, either in S.U.E or Datamine. It's a little bit of away from our traditional survey customers who might use TBC. So the first problem we had to overcome was taking that data and getting it into SiteVision. So the workflow we developed here was to go from DXF, from the mine planning packages, into Trimble Connect and then onto the device. This can be achieved through a few ways. They're looking at setting up teams with Trimble Connect so they can be sent to the survey team or the geology team and so on. Next slide, John, please. So one of the main tasks they're looking to achieve is the visualization of dig blocks. So the image on the left here, you can see where we've got a dig block that's been marked up, but also it has been marked out by the survey team. So you can see the white tape that runs along the ground that was laid out by the survey team, and we can see through the SiteVision screenshot where the surfaces are, which we also use solids, but were viewed in the field. A couple of challenges that were also faced on mine sites is the correction source. So some mine sites will have LTE networks or will have Wi-Fi. Very few will actually have 3 or 4G connect availability for corrections. What we found here was that in terms of accuracy, it's not as crucial in a mining environment to have that centimeter level accuracy. So down in the pit, using the Trimble Catalyst functionality of the device, the corrections we were getting were sufficient, achieving plenty of satellites. You can see in the big picture we have 17 satellites, and at that point we did accuracy of 25 cm, but we did get down below sub 5 centimeters in the pit, which was quite a good achievement. And then in the bottom, the image in the bottom right hand corner, you can see where the taped out dig block actually matches up really well with the surface overlay from SiteVision. Other features that were quite good were the reporting and the recording. the geologist is out in the field. If he spots something, he can actually take an image through the SiteVision app, and it'll automatically send that email with the task back through Connect to the relevant user. The next one, John, please. So also on the side, as I said, we sort of a move away from our traditional survey customer in that the geology department are looking to use it mainly, but there's a lot of on-tap stuff going on site that can also be used. The top left-hand corner, the customer is looking at the possibility for keeping an eye on stockpile designs or waste dump designs, you know, how the plan is matching the actual, what's happening. The survey team also are able to take ownership of utility locating. So actual screenshot from site again of the utilities running underneath that footpath. We've got some power cables on the left and communication cables on the right in gray. And then other items that they're looking at doing is for the positioning of plant. You know, IFC models are very common in that sort of area and work nicely in SiteVision. So the positioning of plant, also exploring whether you can fit plant in certain areas. So that's really they've been using it now they just got it delivered a week or two ago, so starting to ramp it up. But we're really excited for how this is going to work, and I feel that this site will be a leader in WA and SiteVision and give us a real outline of how it can be used and how it can be utilized to its maximum ability.
Thank you, Ian. So if anyone's got any questions for Ian, then please just feel free to put them in the chat. I can see some coming through. So if we don't get to your question at the end, then be sure that I've got a record of them, and we'll make sure that everyone gets an answer emailed back to them over the next few days. So thank you, Ian. Next, we'll jump across to Scott Barling, just out of Sydney in Australia. Scotty.
Thanks, Jonathan. Yeah, I'm Scott. I've been with UPG for about 15.5 years in the GIS space. And traditionally, we've seen a lot of Trimble tools coming out to make it easy for customers to collect their data that they manage, asset information, environmental information, to bring it back into corporate systems. Really nice, efficient workflows but that data has traditionally been available to a sort of few of the internal customers in specialized roles. What's really exciting about tools like SiteVision is that it's taking that data and making it very easily accessible to non-technical people, that presents information in the visual manner that we use every day intuitively. It's just been such a change to the way data is used, data is used, that yeah, you don't have to understand 2D design drawings or have a good imagination to try and work out what a model will look like when you're out in the field. You can take SiteVision out there and it's right there for everyone to see. So yeah, it's been a big change. Got Pedestrian Tunnel coming up. So UPG, SciTech and Building Point, we've got customers leveraging SiteVision for a range of applications. There's many of them, but engineering and planning, construction, to do cut and fill, thematic mapping, as Jonathan mentioned earlier. Underground utilities is an obvious one for SiteVision. Quarries, so as Ian said there, visualizing new facilities, how they fit around existing infrastructure. Very great, great tool for all those sorts of applications. Just going to have a look at some of the clearance measuring techniques that can be used within SiteVision to check on a new design, for example, of a pedestrian tunnel. And the clearances measuring techniques and tools within SiteVision can be used to check for suitable access for construction vehicles, placement of barrier fences, clashes with existing features, etc. It's just easy. That's the big thing I keep coming away with SiteVision. It's easy. You can get out there, measure and share that data with others back in the office. It's such an easy manner. So measuring the height clearance from the pedestrian tunnel here using the EDM to take 2 shots. and showing the calculated slope distance as well as the horizontal and vertical distances. As these measurements are taken, they're stored in the CSV file, which is automatically synced to the Trimble Connect project in the cloud. Measuring between model and real world features, such as the trees there. And as Jonathan said, you could be measuring from the model to a place that you're standing using the GPS, two aspects of the model as shown with the first measurement, any combination. Here it goes. So after that, we've got some examples of from SmartX, who are a civil laser scanning survey company based down in Melbourne, in Victoria, and got some underground utilities. So Jonathan showed a few examples and went into some detail with the utilities and how they can be visualized using the pit view. Laying 2D data over the ground, it's very difficult to understand which pipes or cables run above or below others. With the pit view, it shows it straight away, 3D, which ones are above the others, how they interact. Now we'll jump into the next one. So in the mining and quarrying and construction industries, a couple of retention dams or ponds here. You can see the cut and fill bounds of the works, and it's very easy to keep track of how the project is going. And once again, you can have a site supervisor out there having a look at this data and just instantly seeing progress and sharing it with, or sharing that data with non-technical clients who just want to see, okay, how's my project going? And they can see it instantly.
Thanks, Scotty.
And
thank you very much.
I think Warren's going to be showing a bit of more of the underground utilities. So thank you.
Yep, and I apologies if there's a video in there. I'm not sure how well it actually played for everybody, but I think hopefully you got the general idea. Warren.
Yeah, thanks very much for that, Jonathan and Scott and Ian. Now, I've been involved in the GIS industry in New Zealand for just under 20 odd years, so I've seen a lot of data captured over this time. One of the things that's always come back to me is we very rarely ever see this information ever being utilised back out in the field, which seems to be an incredible waste of some of the resources and times that's gone into doing the initial data capture. Because that's where, at the end of the day, the real value for money comes from the user perspective. Now, Scotty nicely highlighted the fact that this is giving non-technical users a real step up on how to visualize that information. Jonathan, would you like to place the next one there? So I've bought Reveal Infrastructure. I've labeled them as a underground utility asset managers. They're more than just geophysics locators and subsurface engineers. They're actually taking the management of subsurface structures and assets to a new level on how they actually visualize and work with it and what they're actually offering their end clients. Next one, please, Jody. So what's important about where Reveal came into it is that was actually one of the original beta testers for Trimble on this particular project. They saw the value in being able to visualize this information very, very early on. And it's a matter of about, what are we feeding into this? What are we trying to use the system to visualize out in the field? So we can obviously take in our existing data. That's any information that may be coming from an as-built source. It could still be originally from 2D site plans, potentially some survey data coming into that as well. Any of their original mapped investigation work that they may have done themselves, and their geophysics results that they've been using for the GPR work. So that's existing data that may have already been in the ground, but then we can also add in the proposed design work that maybe needs to be shown in relation to the existing assets layers. Now, Reveal use their S.U.E, which is the subsurface utility engineering best practice for quality of data. And they have quality levels between D and A. D is something like we're displaying here, which may in fact be just original paper drawings. It may be seen subsequently digitized and brought back into corporate systems, but really, you know, it was captured a long time ago. A lot of the assets we can only but assume are in the right location, but that's a proposed location of where the information is, but it can still be visualized. Next one, John. But even on subsurface assets, many of them will actually come to the surface at some point. Valves, manholes, grates, grid systems and things there will eventually come up to the surface, and we can use that information to make sure that aligns with our other layers of information that we have. And that sort of gets to a level quality of C there, so we can use that as a guide. Probably more appropriately then, and increasing the level of accuracy is actual the geophysical tracking and locating of subsurface assets, and then marking out. And you would have seen streets and footpaths and things covered in little spray paint diagrams of where asset layers and things are actually being located. Or you can get to the actually doing what's known as potholing, which is, you know, we assume and mark out an asset underground, and the only way to truly identify that that's exactly where that layer is actually to do a small dig to locate that surface. And hopefully it's only a small dig and not requiring an extensive level of mining to locate the actual asset. And that would be the highest quality. So in their case, Jonathan, if you can actually just bring that Instagram video in. So this is a real situation where they've taken a layer, an asset layer, and actually have done a pothole to check to see where this particular layer in is. And as you can see, when they get up to that dug site, you can see a pipe underground there, and that line actually lays directly over the surfaces there, which has given it validation as that is in fact correct. Thanks, Jonathan. Excellent. Just next. So the layers, how Reveal are actually using it, they're incorporating the design work in terms of how a proposed design is going to interact with the environment. This is really great for bringing maybe other stakeholders on site and actually be able to see what the final proposed work is, and it's really good to do on-site consultation work. So I find this very useful. Next there, Jonathan. So in addition to that, you know, you got the dial before you dig type services, but imagine if you can go out with layers of information and make sure that you can already have a relatively high level of confidence that your site investigation works and things are not going to conflict with existing layers of data sets that reside there. It all helps to reduce your potential risk and increases the level of health and safety. Plus, you can also then utilize that information to visualize your as-built-in data against the design data. You know, was the asset placed where it was supposed to? Do the above ground surfaces actually match where it was proposed to do? Because often or not, small design changes in the field do happen, and it does give you an element to provide some authenticity around that and validate the information that comes through. Thank you, Jonathan. Next one.
Very good. Thank you, Warren. So just before we get into the Q&A, there's one little bonus here from Norway, and I came across this just as another example. I came across this video on LinkedIn just yesterday, and I thought it was a pretty nice nice sort of to lighten the mood a little bit, a nice video to share. And it's just another example use case, this time of designer, but using it for a project at home, and I just thought it was a pretty nice example that I wanted to share as well. You can see using the layering to control what's displayed, using the transparency slider. Now they're inside the model, checking the views out the windows. Yeah, so pretty nice project. And again, apologies if the video didn't come through very well there. So last but not least, what's in the box and how much does it cost? Sort of the obvious questions. Since we've got folks, you know, across Australia and New Zealand and around the world, you know, on the webinar here, what I've used is our default US dollar pricing. So this is the price in North America. That if you take the various exchange rates, that's you know, it varies a little bit depending on where you are, but that's just it gives you a ballpark for what the system costs. So there's an upfront cost for the hardware of just over 3,000 US, you know, depending on where you are and what your currency is. And then there's a subscription element to the solution as well. So that's an ongoing subscription. You can pay either monthly or annually, and the amounts are shown on the screen. And what the subscription includes is the ongoing updates to the SiteVision app, the GNSS positioning capability, which is happening within the app, and also the infrastructure around the world that's delivering the accuracies that you saw on the on some of the examples there. And then also the Trimble Connect cloud platform, which is allowing you to share data and collaborate across project teams and in the context of SiteVision to get the data onto the device. And then what's included in the box is the SiteVision handheld itself, and then a number of accessories. There's a couple of batteries, a battery charger, some different bits and pieces. The thing to note there is that it does not include the Android device. That is you're required to buy that one yourselves. And I don't have a list of the supported devices in the presentation, but the couple of guidelines, I guess, is it's Android only, which I think answers a few of the questions that I saw come in throughout the presentation around support for iPads and iOS. And it needs to be running Android 9 and support the Google augmented reality component of the Android operating system. So quick summary, it's a high accuracy augmented reality system specifically designed for use outdoors. It's allowing you to visualize and interact with your data sets in the context of your physical environment, and through that it improves your ability to communicate and collaborate across your project sites. So I'd like to, I know we've gone 5 minutes or so over time now, but I just wanted to put up the data sheet for the SiteVision system and invite those that are on the line to enter some questions, and I can have a look and see which ones we can answer. But as I said, we've got more questions than we'll get through in the next couple of minutes. But rest assured, I will make sure that each of them is answered, and so if you've got a question, please just enter it in the chat. So there's a question here: can you put the model into the phone directly without Trimble Connect? So the answer is no. There is an offline workflow where you can use the system out in the field without an internet connection. And in that instance, you are loading the model from that's stored locally on the phone. but the model has to be delivered to the phone when you were online via Trimble Connect. You can't sideload a model and view it when you're out in the field, and that's because as the model is downloaded from Connect to the device, there's a little bit of processing that goes on that lets SiteVision work with the model. Is it possible to separate the camera and the display? For example, using a USB camera and a larger tablet? So the answer is no. One of the reasons is because the offsets for the camera need to be known extremely accurately to enable the data to be overlaid in the correct place. That's just one reason. I think if I was to perhaps restate the question, I would suggest, it's a request for a larger display on the system, and that is something that that we've heard, and I think we might see something in the future around that. Is there a specific phone that we should use, or an iPad? So I mentioned before, iOS is not supported, it's Android only. And there is a specific list of phones that Trimble has tested and recommends. At the moment, at the top of that list is the Samsung S10 Plus. It's the phone that I use, and relative to the S9 that I've tested before, it's got a much better display that works in sunlight. It's got better battery life. It doesn't overheat in the sun. There's a number of reasons why the S10 Plus is sort of at the top of that list. But there are other devices, and like I said, the guideline is that it's running Android 9 and supports AR Core within the Android operating system. And if you go to the website sitevision.trimble.com, you can find your way to some more information about exactly what phones we've tested and are supported. So can you combine GIS data and CAD files to be used to visualized on site? So I think that's a little bit of a tricky one. When we talk in terms of a model, it's if it's a shapefile, for example, then it's the files that make up that shapefile zipped up. And they can be viewed as one model, so to speak. And then presumably the CAD file would be a separate file that can be viewed by default separately or independently. If you wanted to combine data sets, then it's really a case of when you're preparing your data, putting all of the data you want to see into the same file or set of files, if it's a shapefile, for example, and then perhaps it's a good idea to then use the layers to control your ability, or to give you the ability to turn different elements on and off. You might like to send some more specific info on exact file types or data types for that one, and I can help, or hopefully provide some more information. What is the distance of the EDM? So I think the typical distance for the EDM is out to 25 meters, but best case, we've had it returning distances out to 100 meters. I would caution people measuring out to that longer range, however, because the accuracy with which you're measuring really depends mostly on how still or how steady you are holding the device. So best practice is to do what you can see in the photo on the screen, which is when you're using the EDM, which is to mount the handheld onto a survey rod, so it's as still as possible. But you can imagine if you're holding it in your hand, the ability to point accurately beyond sort of that, maybe 15 to 20 meter range is probably not so good. So ultimately, it just depends on the accuracy that you're trying to achieve, and whether whether you think the technique you're using is going to meet that accuracy target. Can it measure to a prism? Yes, it can measure to a prism. It would depend on your ability to point it at that prism, however, so it's not really a workflow that I would recommend. It's a EDM that's been designed to return distances off most objects in the specified range. So I think that's probably answers that. Can we get a copy of the video? So let me look into that. I think 2 or 3 of the videos shared were publicly available on LinkedIn and Instagram, etc. So let me see how I can publish those links. So there's a question here. Can you send some detailed instructions on how you got 2 to 3 centimeter accuracy on the as-built of the underground utility? So I think the couple of important factors there are you need to have, I mean, the utility needs to be mapped accurately in the beginning. So you need to be, you know, when it's installed, it needs to be captured, you know, within that accuracy range. And then when you bring the model out into the field at a future date and you're sort of overlaying the model onto the ground, or if you've potholed and you know you're looking for that line to sort of appear over the physical utility to that level of accuracy, you need to make sure that you've got GNSS corrections that are delivering that 2 to 3 centimeter accuracy, and you need to make sure that the coordinate systems and everything is set up correctly. So when you start getting into the finer details of the coordinate systems and how the various technologies work together, it's, you know, there are some corner cases where it requires you know, more investigation exactly how to make things work. But I think it was Ian who said, or Scott, sorry, who said that you know, one of the things that he sort of takes away from the system is just how easy it is to use, and under most normal workflows or circumstances, it is very easy to achieve those levels of accuracy. But again, or depending on the accuracy of the data or the model that you're using. So there's some questions about availability in different countries and which distribution partners are the right ones to contact. So I'll contact you guys that have asked those questions independently and provide that information. So can you record video? You cannot record video. It's only recording, or the task creation is taking a snapshot of the scene or of the view. It does not record video. There are some applications that you can put on your phone in parallel that allow you to record the screen, and we use that sometimes for training and things like that. But within the SiteVision app, there is no ability to record video. Are there any size limitations to the models? Yes, there are. And again, I can point you toward more information on that because I don't remember the size restrictions off the top of my head, but it's actually more dependent on the complexity of the model as opposed to the pure size of the file, if that makes sense. So it looks at the number of triangles in the model, and there's a maximum number of triangles as opposed to a maximum, you know, file size in terms of megabytes. So I can send more information on that one. We're getting close to the end of the list here, guys, so just bear with me. Is point cloud data supported? So in theory, it would be possible to load a point cloud and visualize a point cloud, but it's not. It would be sort of a funny workflow. It's not a workflow that we've designed the system around. So I think for all intents and purposes, the answer would be no. But depending on exactly what you're trying to achieve, then you know there are probably ways to bring the data in. Okay, so there's some other questions in there. I think some of them are a little bit too involved to do justice to just you know in sort of a 5-10 second answer. So I will I'll leave it there. Those that are still on the line though, just for fun, before we close out, I've got a 1-minute video that I wanted to share with you. And this is, you know, augmented reality, virtual reality, these technologies, they seem reasonably new, but Trimble's actually been working on this type of stuff for quite some time. So the video that I'm going to share here is from, I think, about 1997, and it shows some of Trimble's early development in this space. So I hope the video plays. If nothing else, hopefully you can hear the audio, but it's just a bit of a fun way to close the webinar.
Computer graphics in real time into the user's surroundings.
It uses software that's been co-developed by companies HitLab and Trimble. This system's still in its development stages. They want to make it lighter, smaller, and cheaper. But to see more of this house, I need to put this on. Let me walk through the house, even look out the window at the real world.
You can see a house before it's built, so you can say, I'd like to add a new room. The prospective buyer can say, let's change the color. The road engineers can problem solve in the field. We have a native tree. We need to move that around.
So just a fun way to end the webinar there. Thank you to Ian, Scott, and Warren for their contributions, and I'll put their contact information up on the screen here, and I'll leave it for a minute or so after we've stopped talking so that you can get the contact information if you so desire. But I hope everybody's safe and well, and thank you once again for dialing into the webinar.